Hi everyone, I'm Daniel at QNAP, and I'm here to talk about QNAP's storage management features. And that's because we offer a lot of flexibility and control in how you set up and optimize your storage. So for our agenda today, we're going to talk about some of the problems that businesses face with setting up their storage and some of the solutions our storage management offers. We'll go over kind of an overview of QNAP's storage and snapshots. Storage and snapshot is where our storage management features are located. And then we'll go over feature highlights and a live demo on how to use this. So what more and more businesses are finding out is that one size does not fit all for their storage. It's getting more common to have multiple different storage needs. And for each kind of storage, they might have different requirements. Maybe for one storage need, they'll need a lot of capacity. For another storage need, they might need a lot of performance. Another storage need, maybe a lot of redundancy with backups. And what more and more people are finding is that to try to have a one-size-fit-all approach, to try to fit all of their storage needs into the same kind of storage would cause all kinds of problems. Maybe they won't have enough capacity if they try to make all kinds of storage the same, or maybe they'll have lots of capacity but not enough performance. Or if they try to have high capacity and performance for every kind of storage need, maybe the price just shoots through the roof. So there's really a need to set up and optimize your storage according to your needs. And so our storage management software gives you the control and flexibility to do that. So QNAP storage management helps with safety. You can easily configure RAID groups for redundancy. You can also monitor the health of any HDD to help or SSD to help prevent data loss. For performance, you can set up storage pools to meet various performance requirements. And you could accelerate the performance of your storage with SATA SSDs or NVMe SSDs. For affordability, our Qteir or SSD Cache can accelerate cheap, affordable HDD storage, and this lowers the cost of high performance. For capacity, you could easily expand or migrate your storage without shutting down your system, without losing your data, just easily expand or change your RAID, and you can flexibly expand or you could add new volumes or expand your volumes. You can set them up with thin or thick provisioning. For security, we offer encryption. And also for security, we offer snapshots. Snapshots give versioning. It's the ability to undo a mistake or very quickly recover from a ransomware attack. So this is the basic structure of how our storage management is structured. By the bottom, we have our physical hard drives. Our hard drives would be grouped into various RAID groups, and various RAID groups can be combined together into one giant storage pool. And from your storage pool, you can make one or multiple volumes and LUNs on the storage pool. And from within volumes, there could be multiple shared folders. So this is a basic structure of how it's set up. Kind of go more detail of how we make our storage pool. In this example, we have one group, a RAID 6, 4 drives RAID 6, 3 drives RAID 5, and 4 drives RAID 10, and all these different RAID groups are combined into one giant storage pool. And in this case, we have an expansion unit connected to the NAS. So we have 2 RAID groups on the NAS, 1 RAID group from an expansion unit, and in this case, the storage pool is made up of all 3 RAID groups. You can do this however you want. You could make a separate storage pool for different RAID groups, or you can make just one giant storage pool, however you choose. So some of the feature highlights of our storage management software is you can choose JBOD, or you could choose RAID 0, RAID 1, 5, 6, 10, or even 50 and 60. We support thin or thick provisioning when you set up your volumes or LUNs. We support AES-NI hardware encryption. We support SSD Cache and Qteir. And snapshots, as well as snapshot replica, We'll go into the difference between those two later. And we have the smart monitor of your disk health so that you can see if there's a problem and maybe replace your disks before they go bad. And we support RAID migration or storage expansion. So what is RAID? RAID stands for Redundant Array of Independent Disks. So RAID 1 is disk striping. That's basically when you upload or download to the NAS, you split up the file to upload or download to all the disks at the same time so that you can upload or download much faster than you could to one disk. That's what striping is. RAID 1 is mirroring. It just means that one disk copies the other disk. So if a drive dies, you still have all your data. And RAID 5 and 6, they offer striping, but also redundancy. So with RAID 5, if one drive fails, you still have all your data. RAID 6, two drives fail, you still have all your data, but they also offer the striping for added performance and also more storage than you could fit on just one drive. RAID 10 is a combination of RAID 1 and RAID 0. RAID 10 is basically multiple RAID 1s striped together like you would in RAID 0. RAID 50 is multiple RAID 5s but striped in a RAID 0. RAID 60 is multiple RAID 6s striped in a RAID 0. And it's very easy to set up your RAID from our GUI with just a few clicks of the mouse. So RAID 50 and 60 is somewhat new to QNAP. We've offered it for a little while now, but it's one of our newer RAID offerings. And in this example of this RAID 60, you can see you have a RAID group of 3 disks, a RAID 5 of 3 disks here, and another RAID 5 of 3 disks there. But these two RAID groups are striped together, meaning that when you upload or download, you upload or download to both RAID 5 groups at the same time. And that makes it faster than just one RAID group, faster than one RAID 5 group. Now for RAID 50, you need at least 6 drives. And for RAID 60, you need at least 8 drives. And RAIDs 50 and 60 offer better IOPS and better throughput while still offering good redundancy. This is kind of a comparison of our RAID groups, how they might perform. So RAID 5 needs at least 3 disks. RAID 6 needs at least 4. RAID 5 lets you have at least 1 disk failure. The capacity on RAID 5 is very good because it only costs you 1 disk worth of storage. RAID 6 costs you 2 disks worth of storage, so the capacity is a little bit less. RAID 5 has a little better performance than RAID 6. RAID 10 will cost you half of your storage for redundancy, so the capacity is the lowest, but its performance is very high, and it offers you a decent amount of safety. At least 1 drive could fail, but if drives fail from different RAID 1 groups, then you could have more than 1 drive fail and still keep your data. RAID 50, it has pretty good performance, and the capacity is still pretty good. And then RAID 60 would have a little bit less capacity than RAID 50, but it offers a little more redundancy. So just for some hints for choosing your RAID configuration, you might want to think about safety, performance, capacity, and affordability. So some of our safest RAIDs would be like RAID 60, RAID 6, RAID 10, or even RAID 50 is fairly safe. For performance, RAID 0, RAID 50, 60, 10, or 5 would all have really quite good performance. For capacity, RAID 0, 5, or 6 would offer you very high capacity. And really affordability and capacity would be the same numbers. Basically, whatever gives you the highest capacity from your drives will be the cheapest per terabyte for storage. So affordability, capacity is the same RAID configurations. Well, once you've set up your storage pool and set up from a storage pool, you can then set up volumes. You could either make one just single static volume. This offers the best performance, but it doesn't have our advanced features. You can also set up a flexible volume on top of a storage pool, and that offers all of our features. And from there, you can set up either a thick provisioning or thin provisioning, and you could then set up multiple volumes or multiple lines of either thick or thin provisioning. The way thick provisioning works is, let's say you set up a 2 terabyte volume. Immediately it's going to allocate all 2 terabytes from your storage pool so that nothing else can use those 2 terabytes. And this offers a little bit better performance than thin provisioning. The way thin provisioning works is, say you set up a 2 terabyte volume, it will not allocate those 2 terabytes. Instead, it allocates data to that volume as you write to it. So if you write 10 gigabytes to that volume, it will allocate those 10 gigabytes as you write. And then whatever part of the volume is not allocated, actually other volumes or lens could still use that space. So thin provisioning is more efficient in how it uses your storage capacity, but it's a little bit, has just a little bit less performance because it adds an extra step whenever you write to that thinly provisioned volume. There's an extra step of you first have to allocate the space as you write it. So that extra step of allocating as you write makes it just a little bit lower performance, but it's a better, more efficient use of storage space. So that's kind of the trade-off. So here's kind of pictures to represent static, thick, and thin. So for static, you have your RAID group, and your RAID group is your volume. So it's just very simple. Your RAID group is your volume. But for thick provisioning, on top of a RAID group, you have a storage pool, and on top of a storage pool, you have you can make multiple thick volumes or lens. And so the thick volume is a little bit less performance than static volume, just because there's an extra step of translation. So for static volume, your volume is your RAID group, but for a thick volume, there's this translation from a split space on the thick volume translates to space on the storage pool, translates to space on the disks. So there's just a little bit of extra translation involved, and that's why the best performance is static volume. But really the performance cost is I'd say fairly small, so I still do highly recommend thick or thin provisioning. And here with thin provisioning, it's the same same as thick, in that you have volumes on top of storage pool, but with thin, it's just a little bit of a performance cost for that allocate upon write. So we offer, for kind of security reasons, we offer AES-NI encryption. This means that even if your hard drives were stolen, people would not be able to access the data on those stolen hard drives. We offer hardware accelerated encryption so that you can still have good performance even when you have encryption, so you don't have to compromise between performance and security. We offer FIPS 104-2 standard. That's a very high level of encryption, extremely hard to crack, and you can protect that with either a password or a key file. For performance, we offer SSD Cache. SSDs provide high random IOPS and also good sequential performance. Could be great for multi-client, accelerate multiple volumes or lens because it's a global cache. The price of SSDs has dropped in recent times, so it's really a good time to buy SSDs. It's very easy to create a cache with just a few clicks of the mouse. And you can now even upgrade to NVMe SSDs for your storage or cache with our new higher performance QM2 cards. So you have many different options on how you set up your cache. You can set up read-write cache, read-only cache. With 4.3.5, you'll soon have the ability for write-only cache. For your cache, you typically group multiple SSDs in a RAID for a greater capacity of your cache and greater performance of your cache. So just for example, maybe for like a file server, it might be common to set up read-write cache. It might be common to set up your SSDs in maybe a RAID 10 or RAID 5. For maybe a web server, read-only cache might be more common. And then maybe you might set up your SSDs in either a RAID 0 or maybe a RAID 5. Maybe for an like online media editing, read-write cache RAID 5 might be common. You just have many different options. Just you choose the RAID configuration of your cache. You choose read-only, read-write. Soon you'll have write-only. You can choose accelerate just random IO or random and sequential. You have many options with your cache. We also offer Qteir, automatic tiering. So this can just automatically move the data that is used most frequently, automatically move that, relocate that to your higher speed, either SSDs. We can have a SATA HDD, or you can have SAS for like a mid-level tier, and then SSD for your fastest tier. And Qteir can just look at what data is being used most often, moderately often, least often, and just relocate data according to how often it's used. Most used will be in your fastest storage. An advantage of Qteir over cache is that with Qteir, the size of your SSD tier is not dependent on the amount of RAM that you have. So you can have as much SSD capacity in your SSD tier as you want, regardless of how much RAM you have. And here's kind of the three tiers: SSD tier, SAS tier, SATA tier. And so you can set a schedule of when you want the Qteir to do this automatic tiering. That's when it checks to see what files on average have been used the most, moderate amount, or least, and then relocate those files accordingly to either the fastest, moderately fast, or least fast storage. You can set a schedule for when it does that tiering. So Qteir and cache work a little bit differently. For cache, data is duplicated to SSDs. With Qteir, data is relocated to SSDs. This means that with Qteir, your SSDs increase your total amount of storage because the storage is either on the SSDs or HDDs. But with cache, it is not relocated, it is duplicated, meaning the same data on the SSDs is also on the HDDs. So cache will not increase your total amount of storage. So those are kind of how they work differently. So with Qteir, you have the option of choosing what folders you want to apply Qteir to. So maybe you have data, maybe one folder has data that performance doesn't matter so much. Maybe you won't apply Qteir to that folder. And then you can just focus on the folders where you really care about performance. So choose Qteir on or off for any folder you choose. For security protection, we have Snapshot and Snapshot Replica. So what a snapshot is a record of the state of your data at a particular point in time. Then you can use that record to restore your data to how it was at the time of any snapshot. The way our snapshot uses copy on write, these are block-based snapshots. And copy on write, the way that works is that whenever a block of data is getting overwritten, that block of data gets copied to the snapshot. That way, when you load the snapshot, you can just copy that data back on so that you can make every block of data exactly how it was at the time of the snapshot, just by restoring the block from the snapshot. When every block is as it was, then every file is therefore as it was, and your system is restored. And we support block level snapshots for both volumes and lengths. Now, snapshot is not a backup. Snapshot is versioning. So if your maybe hard disks were to all die, NAS got burned up in a fire, you still lose your data. But snapshot replica is a backup. So snapshot replica allows you to replicate a volume or len to another NAS or even to multiple NAS. And so a snapshot replica is a backup with versioning. And then from your snapshot vault, you can access any of your snapshot replicas, and you can restore a snapshot from your snapshot replica on another NAS. Something else to protect your data is our smart disk health check. So this can just give you information on the health of your drives to let you know, is a drive in danger of failing? Do you want to replace that drive before it fails? This just kind of protects you from losing data. Now, as far as for protecting your data or expanding your data, we support RAID migration. So RAID migration is when you migrate from one kind of RAID to another kind of RAID. So you could, for example, protect your data by migrating from RAID 5 to RAID 6 to add extra redundancy that way. So you just add another hard drive, and when you add another hard drive, then you can migrate to a RAID with maybe more redundancy. We support migration from single disk to RAID 1, from RAID 1 to RAID 5, or from RAID 5 to RAID 6. So just add a drive, and then you can migrate. We also support RAID expansion. RAID expansion is when you keep your same RAID type, but you add a drive, one or multiple drives to your RAID type. So in this example, we have a RAID 6 of 4 drives, but we're adding a drive to it to make it RAID 6 5 drives to increase the capacity of that RAID 6. Or here we have a RAID 5 3 drives. We're adding a drive to make it RAID 5 4 drives to increase the capacity of that RAID 5. So RAID expansion is when you keep the same RAID type, but you increase its capacity by adding one or more drives. Now we also support expanding your storage pool by adding another RAID group to it. So not only can you expand the storage of your RAID group, but you can expand your storage pool by adding another RAID group to it. And in this example, we're adding a RAID group from an expansion unit. So in this example, this storage pool is made up of one RAID 6, one RAID 5, and one RAID 10 from an expansion unit. And all those 3 RAIDs together make one giant storage pool. We have expansion units that connect through SAS. We have units that connect through USB and units that connect through Thunderbolt to easily expand your storage. You can also expand your storage with virtual JBOD. That is basically where you allow one NAS to share its unused storage with another NAS. It just makes an iSCSI LUN and maps it onto another NAS. So now it's time for a live demo. Let's just go over some of these features. So this is our storage and snapshots here. Let me kind of go over how you get there. So from here, just click on storage and snapshots. So here's kind of an overview of the storage. You can see free space on this NAS, 3.2 terabytes. Have a thick volume there. Some reserved space for snapshot. Here are my drives. These are SSDs. These are HDDs, I believe. No, these are SSDs. These are HDDs. SSD 1, SSD 2, HDD, HDD, HDD. So here you can check kind of disk health. So this is my NAS. So here's disk health info. This is a summary, but you can go to the smart information. Gives you a lot of information on each disk. So just choose any disk to check out the health of that disk. And this is kind of where you can kind of see how our storage pool is structured. So here we have a storage pool, but on top of that storage pool, you can make multiple volumes. So here I have my system volume. Now, from the storage pool, you could easily create a new volume if you wanted. You could create an iSCSI LUN, whatever you want. You can click Manage to manage your storage pool. So here you can see in my storage pool, I just have 2 disks put in RAID 1. And it's just very simple. And you can easily expand your storage pool. So here when I show you here expand, I can expand by adding a new RAID group, or I can expand the existing RAID group by just adding more disks to the RAID group. And I'll demonstrate that in a moment. But first I want to kind of go over Qteir a little bit. You see here we have, I have Qteir set up. That's what this little symbol means. And easily from File Station, I can control which folders have Qteir applied to it. So here, download folder, you see there Qteir is applied to it. Right click, I can disable auto tiering. Qteir no longer applies to the download folder. I can enable auto tiering. So you can just enable, disable to any folder you want. It's very simple. Now from the volume, you can see the snapshots. I just recently set up this volume, so I've only taken one snapshot so far. But I go to Snapshot Manager, and here I can see my snapshot. From here, if there were more here, I'll just take a snapshot right now. So now I have two snapshots. And so if I just want to revert to the time of any snapshot, I just click on that snapshot, and I could restore a specific file, or I could revert the whole snapshot. So here, I can click on any folder, restore the folder. I can click on a file, restore the file, or I can click revert volumes. This reverts the whole volume to how it was at the time of the snapshot, or I can revert a specific folder, or even just a specific file. It's very simple. So this is our cache. I'll set this up in a bit, but I'll do this on another NAS. But first on this NAS, I'm going to go back here. I'm going to expand my storage pool. I'm just going to expand my additional RAID group. These are the two disks I'm going to add to my RAID group. And I can just click expand. And it's warning me that the data on these new disks will be erased, but that's okay because I don't have anything important on those new disks. This will not cost you the data in your storage pool. So whatever data is in my first storage pool, I keep that, but just new disks are what get wiped, since they're being added to my current storage pool. And so now you can see I've got 4 disks RAID 5. Now I'm going to set up caching. I'll set it up on a different NAS because I have Qteir set up on the first NAS, so I'll set up caching on this NAS. So I will just click Cache Acceleration. I'll just click Create, and I'll choose the SSDs I want to use for cache. In this case, maybe I can choose either RAID 0, RAID 1 when I just have 2. If I had more SSDs, I'd have more options. I'll choose RAID 1. Maybe I'll choose read write. Next. And I can choose to just accelerate random IO. And then here is the bypass block size, basically how big of a size should I cache? Like, should I say size is bigger than 8 megabytes, bypass the cache? Size is bigger than 32 megabytes, bypass the cache? Just kind of choosing how small the files you want to cache. Or I can choose sequential. This will just cache everything. Any file I open gets copied to the cache. So maybe in this case, I'll just choose accelerate random, and I'll choose maybe 8 megabyte. Next, and you choose what volumes you want to apply the cache to. We have a global cache. You can apply it to any volume, any len, or all your volumes, all your lens. So I'll just apply to these 2 volumes. And it's that simple. So that just sets up the cache. So to kind of just go back here, you can see that it is doing the RAID migration now. The NAS is still running. It still works. No downtime. It's very, very simple. And you see here the cache is on. So whenever I read or write to the NAS, the cache can accelerate it. And this is just some information hit rate. So basically, when I write to the NAS, it writes the SSDs first, that's a hit. When I read from the NAS, if it's a file I've opened up recently that's already in the cache, it'll read from the SSD, that's a hit. So things like that. So this is kind of what you can do with a storage manager. You have huge flexibility to make volumes, to make LUNs, thin, thick, things like that. So from this storage pool, I could create a new volume, maybe I will. So I choose what storage pool to make a volume from. I'll just do from storage pool 1. Next, I'll make this volume smaller than that. I'll just make it 1 terabyte. But you can choose, basically, you can set to max. You can choose to just use it. That will use all of your available space in the storage pool, or you can make it smaller. Next, and there I go. So making a volume is very easy. Making a new storage pool, very easy. Adjusting, using Qteir, choosing what folder you apply it to, very simple. So this is kind of what you can do in our storage management. So, that's pretty much what I wanted to demo. I want to say thank you for listening. And now that you have this ability, you can optimize your storage however you want. So for example, maybe some businesses, they might choose to put their database on SSDs, maybe their VMs on an SSD storage pool, maybe file server on HDDs accelerated with SSD cache. Maybe you have another NAS that they back up to, but because it's just backup, maybe just HDDs. So you have many different ways to optimize your storage with Storage Manager. So I just want to say thank you for listening.